It's very important to really understand the why. And the why is not just a single question or a single answer too. So as we now talked about the problems, the science behind the standards, what is a weather-resistive barrier, the engineering behind, how does it apply in roofing, how important airtightness is, and also about the thermal bridging, which is a very, very small part from the study, of course, but it's also important. We can talk about for hours and hours about the why, but it doesn't help us if we don't know how to execute it, or if you don't have the right people how to execute it. So very often we hear like, is it even possible? And it won't happen on site. The idea of the rest of the presentation is actually the proof that this is happening on site already for many, many years. And that's the good part. So all these following pictures, most of them are pictures from social media, from all the premium builders. A few of them are here tonight, and you're going to see what they're actually doing out there. And to follow the line how you build a house, I would say we start with walls. And as we said before, if you use a quality product or a quality wall membrane, you just run the wall membrane and it should be right, isn't it? If you install it nice and taut. Because the quality of the membrane is actually what you need. So job done. Or if you look a little bit more into the detail, we have actually fixed things because we actually have to hold the membrane in place. So in the first 10 seconds, you already start to penetrate the membrane. So you actually have to consider what's actually happening with all the staples to the membrane. So if you have wind pressure on the membrane, you stress the staple connection. So is this the best result? How to fix your membranes? How you can do it a bit better is definitely using stinger washers. But still you penetrate the membrane. So every penetration is a potential hole under some conditions. And the same is with brick ties. If you have brick ties specifically, they have these sharp corners. They would easily just penetrate the membrane over the time because you have the wind pressure, positive, negative. That's why you see we have the Nidec tape, butyl tape in behind to protect the membrane. I definitely would say there's a better way how to install it. And the idea is just to simplify it. Just put battens on top. And as you know, thanks to Jesse now, we actually always want a drained and ventilated system on the roof and as a wall. It also has the benefit of actually supporting the structure and strengthening the structure. Because when you have wind pressure hitting the membrane, this is actually the stress what's happening on the membrane. So you don't want the staples to handle the stress, you actually want the battens to handle the stress. If you have brick ties, just fixing in front of it and you don't have all the problems with the sharp corners. So as we now know, we actually want to support the membrane. You also need a drainage layer because if water is getting behind the cladding or if you have condensation, we need a drainage layer, but you just need 2 millimeters for a proper drainage layer because that's all you need to break the surface tension of the drop. But 2 millimeters is not a lot. So it's maybe you fold up newspaper 3 times and then you got your 2 millimeters. So it doesn't sound very right to me. So it's not just all about drainage. It's also about ventilation. And to actually create a proper ventilation layer, you need something around 20 millimeters to allow free airflow. So let's talk about the ventilation in walls. An important part is first, air has to get in. Where air will get in, water will get out, of course. So it means, okay, you need a proper opening on the bottom. And based on a study of the Lund University in France also, they actually would want to have at least 10,000 millimeters square per linear meter. But this is actually just 10 millimeters, isn't it? And just before that 20 millimeters. It doesn't end up. That's weird. Let's have a look why. The thing is, if air gets in, air has to get out too. So at least again, we want 10,000 millimeters square per linear meter, so for air to escape. So why the 20 millimeters now? The 20 millimeters is the important part because you need a cavity closer. First of all, because you want to stop vermins to get in your structure. Whenever you put cavity closers in, you actually reduce the opening. A common one I use on my projects is the one on the right bottom, because I know it's 50% opening. And if you have your 20 millimeter gap where you reduce it by 50% due to the opening range, then you have your 10,000 millimeters square per linear meter. The opening will change again if you go into bushfire zones, because then the mesh has to be actually get finer, because the opening rate should be less than 2 millimeters. But you still have the same system. So one way how to do it, you use the flexible mesh. The tricky part here is the flexible mesh, or the mesh is flexible, and the membrane behind is flexible too. So you might have a gap. So I think the better version of it have actually a rigid, banded, custom-made banded cavity closer. And if you actually have these fire requirements, you just put a thin strip of the fine mesh inside, but you still have something rigid. So I think this is going to be significantly more durable instead of a flexible membrane. And having a drained and ventilated system is not just important when we talk about systems with the cladding on the outside, it's also important when we talk about brick veneers. And when we talk about brick veneers, we just care about the weep holes, but we don't even consider ventilation. And I think it is actually important to have proper ventilation and not just drainage. So we actually have to look into the detail to see what is the actual opening rate. So I'll just try to calculate the opening rate of one weep hole, which roughly is going to be 460 millimeter square per linear meter, which is roughly just a 13th of what we want to have if you have weep holes every fourth brick, which is standard. So if you now would introduce weep holes in every single brick, you're still quite far away of a proper ventilated area of 10,000 millimeter. You just end up with a third of it, roughly. So maybe the only way what you can do is actually introducing the ventibricks. Quick picture, yeah. And what's happening with the wind pressure is what we want to talk about, because even doesn't matter if you have a brick veneer building or if you have a standard build with timber cladding FC sheets, you always have wind hitting the building. We just have to look outside the window today. But what's happening with the wind? Do the bricks hold the wind back, or is the wind pressure actually being held back by the membrane? And it's actually the membrane, so the membrane has to live with all the stress. And what's happening when we go in high wind zones up north? Like this building is in Ballina, for example, so they have really massive wind loads. In this case, you might need a solid board because you actually need to distribute the stress of the wind and the power of the wind. And in this case, you would also introduce a peel and stick membrane, because this would make the system significantly stronger. In this particular case, it's also an airtight layer. So they have 90 millimeters insulation between the studs. Now the important part is they have additional 60 millimeters on the studs, because now the airtight layer is relatively in the middle. But this just works with the hydrothermal analysis with WOFI. Also, using peel and stick membranes, a positive side effect is you always get very airtight. And I think that might be the best airtightness result we have so far in Australia with 0.08. I think it's pretty good. I think it's a very good system for walls. I guess also for roofs. Because for roofs, we know you have the bracing strips which might penetrate the membrane. So having a sheeting board on the roof and the peel and stick membrane, the bracing of the roof is definitely superior. And it's much safer to work on too. But whenever you use solid boards, actually having this drained layer is significantly more important than normal, because you don't have any flexibility. So you can't actually hope that you have accidental drainage layers. And the wall wrap is always perfect if you try hard. Or the wall membrane is just as perfect until you start to penetrating. And one of the most common penetrations are actually cables. So we have these nice grommets for cables. The only tricky part is that in Australia and New Zealand we have flat cables. The rest of the world has round cables. And these kind of grommets are actually made for round cables. So if you really look into detail, you actually can see that we have the corrugations of the cables. So it's going to be very hard to actually stick the tape in between. So to get 100% seal on this system is definitely not possible. One step better is actually if you would use taped systems, but you have to be very careful and passionate about also to stick the tape properly together. So you always stress a little bit the tape. So I still wouldn't say that's actually the best solution we have. I think the best solution is actually using conduits. Having a pipe offcuts and a grommet and using conduits, you run your cable through. You have maximum flexibility while you build your building site. And when you're finished, you just fill it up with Orcon, the liquid adhesive. And then you actually have an absolutely tight system. And it doesn't matter if it's about air tightness or weather tightness. It's much better than running cables through your structure, in my opinion. And the same with data cables. You don't want to have data cables during your construction phase running around the building site because they're expensive. So I think the perfect seal is actually possible. But we don't just have pipes, cables. We also have pipes. Should have drank more water before. So use grommets for the pipes gives you all the flexibility too. But there are also ways if you, for example, accidentally miss the grommet, you can't use it for any reasons. So that's why we recommend definitely using a stretchy tape. It's not the best solution, but I'm just saying it's possible. At least do it before you don't do it. The use of grommets is very important because if you try to stretch the tape around pipes, they're always going to shrink back because there's a lot of stress to the tapes. So that's why the use of grommets is significantly important to make the systems work inside as outside. I think this is one of the easier penetrations because a big topic is always windows. And I think there's a big history about windows and windows that fail, that leak. So let's talk about the history a little bit. And one of the weak points is always the window seal, of course, because water will sit on the window and it start to rotten away. So first step of all, you always try to protect the window seal. So that's why these specific seal tapes, they're there to protect the window seal. If you ever would have condensation, staying water, or bad installed window, water would get into your structure. It actually wouldn't sit on the window and the timber. It would actually sit on the window sill because this is absolutely watertight and vapor tight. You stretch it around corners, so it's definitely a better way to stretch around corner than to tape it because you minimize the risk of any water increase in the corners. And also, the use of press fix is actually not a bad idea because having to pressure activate the tapes and really work into the corners. So even the doggo here has a nice press fix. Also important is actually how does a window work? And that's why I just scribbled up last night. These are the principles of windows. So when we talk about walls, we know we have weather resistive area on the outside. We have an air tightness layer on the inside, insulation between. The same is happening with the window install, just a much smaller scale. So you have weather tightness on the outside to deflect water, but actually the back seal of the window is very important because when you put a back seal on the window, it depressurizes the installation and the window is going to be significantly more resistant to leaks. And of course, I would recommend to fill it up with insulation or spray foam. And also important is the window install, the taping of the window should be always consistent all the way around windows. Always. So when you pre-install the window here, you see the tape is going all the way around in one piece and then you just join it together in one part. And the same is when you have it on the outside. Yeah, on the inside, sorry. So you have one tape for the inside and one tape for the outside. The specific tape is a window installation tape. You could use also standard tapes, but the sequencing is always going to define your outcome. So for example, if you install the battens around your windows way too close and beforehand, you'll see you can make your life a little bit difficult here to install your window properly. So that's why I would recommend leave the battens off or leave them shorter around the windows. Also with packers, we are not a big fan of packers because the ideas of counter battens is actually having consistent support of the membrane and not just point fixings. And same here with the metal top hats on the outside. What's your thought here? Thermal bridging, yes, no? Trick question, no, it's not. Because it's actually on the outside of the building. So as with the packer, it's separated from the structure. It's actually no problem at all. I would have a problem if it would have been directly attached to the membrane. So that should be fine, in my opinion. So that's why keep your batten shorter around the windows, just screw them on, don't nail them on, because if you want to remove them, you save a lot of time and trouble. Also, if you decide to pre-install your window before you actually wrap the walls, which is actually not very common these days. I was hoping that Hamish comes tonight and explain himself why he did it, but he just gave me a quick call. The reason is actually that's a hempcrete as a hemp building, so that's why they had to pre-install it. So now we know at least on the last day. So, but you see, he has to put in quite a bit of effort to actually get it right, to pre-apply all these tapes and wrapping in the window opening. So if you want to do it the old school way, where you pre-install the window and then the membrane later, it takes more time and effort to get it right. So that's why let's go with time. As a thing, we have a good understanding for walls. Now we have to think about the roof also. And it's always a big topic. And the first thing is, can you actually install the roof membrane on the old school way? 4200 part 2. Technically, you can. Technically, we can. You can actually drape our membranes over the purlins, but it's not what we recommend because you want to have the best outcome of your roof. The thing is, if you drape the membranes over the rafters, you might allow free water flow to the eave until it hits the ponding board. We all know the pictures when the membrane, you try to get it into the guttering, and then you have this massive water pools in all the spots on the eave lining. And that's a bit of a difficult one. Also, it's difficult too because you really have a lot of airflow, accidental airflow in your roof system. And it's not a proper ventilation, it's just an accidental airflow. That's the big difference here. So that means you also minimize the performance of your insulation if you don't calculate it. So that's why the better way is have a nice and taut installed membrane. Even better if you have a solid sheet to support the membrane. Using membranes with an integrated tape because they make your life significantly easier. I think it's not the most comfortable idea to run around on your roof with a tape and try to tape it because the membrane is flexible. You try to balance over the roof, so it's better to make your life easier and safer. And as you tape the overlaps, you don't have any wind washing of your insulation. Also, it allows you a free drainage layer from top to the bottom because you don't have any ponding, nothing slows the water down. That's very, very important because you always will have, thanks to chassis as we know now, condensation on your roof. You can't avoid it. Also important is, of course, you have to use materials and membranes on the roof which actually are UV resistant. This means because the UV intensity is significant more on the roofs than on the walls. And just be aware of it that it's an important part of the system too. And for the best outcome, the installation method is significantly different also. So now we actually would install the membrane first and then counter battens and then battens. It means now you can't just run the roof up and down anymore. So in this case, you actually would work in sections or sequences. So install the membrane, you put the counter battens on, purlins, and then you move on step by step by step. And I think it's quite effective too. Because you know when you finish there, your roof is actually ready to be sheeted. Always the most important part is where I get the most questions is actually about the wall and roof connections, because there's so many different ways how to do it. I'm not saying there's one way how to do it right, but I think there are quite a few ways how to do it right. One way is more like, this picture is definitely 5 years old. You could technically stick the membrane on the other side of the mentor product, but taping it around the rafters and getting it really tight all the corners is definitely a bit of a tricky one. But you see, this is a dedicated layer where they try to connect both layers together. But it's definitely going to be labor intense, and if the roof membrane is not installed properly, then it's going to be very hard to press and activate the tape underneath the membrane. That's why a thing like really wrap your building as a Christmas present is definitely the best idea. You still have to tape around the rafters, but you see you don't have any airflow into your structure, and your building is completely wrapped. So that means water shouldn't get in here at all. And taping around the rafters can be quite time intense because you have more than 10 rafters normally. We talk about 60 to 80 rafters per house or rafter ends. So they all have to be taped. I just want to mention the counter batten here because this looks to me like 5mm counter battens. That's definitely not a proper ventilation layer. So just having a bit more would be definitely beneficial. So how do you cut down now taping around the rafters? And I used my gray brain cells over the last year or two. And I think I came up with a solution where we can save a lot amount of time. So we don't actually have to tape around the rafters anymore. You can actually staple it on and then you spray around. And you can maybe seal 100 rafters in maybe 2 hours. So I think it's going to be significantly faster than actually carefully taping around it. Because I know there are a lot of people in here who actually really going to tape perfect. It's going to be much faster. Or you just completely avoid having any penetrations to your layer and think way out of the box like Evan in Newcastle. And he's actually wrapping his building like a Christmas present, and doesn't matter what overhangs he would like to have, like here on the eave or on the gable, he just adds them on. So you see, for example, the eave lining is actually pre-made in his factory. So he just comes on site, screws them on, 2 hours later, done. The gable overhang is just made with the purlins from the roof. And you see the detailing around is so simple. So you save a lot of time if you have the chance to follow this system. But also, it's quite important to really consider how we actually ventilate and drain the eave. And one way is, what I see once in a while, is you actually stick the membrane on your metal fascia. Just be careful, because these membranes are not designed, or no membrane actually is designed to be permanently exposed to the sun. And very often you look around all the buildings, you see like that the foil is draping into the gutter. It works for a few weeks, months, and then sun will definitely disintegrate the product and there won't be nothing left. So when you follow the system, it have to be important that you really pull it taut on the bottom part so you don't end up with a pond. And also what you see here, he used a mesh which with a relatively small opening, and you're going to have enough overhang of the roof sheeting so it's properly protected. So that's what you have to be very careful of, in my opinion. You also could actually preload the membrane behind the gutter system. So in this case, you would actually drain and ventilate the whole roof structure behind the fascia board. And that's definitely the better way how to do it, because very often I get the question, I want to drain it into the guttering. And it's quite a bit of a German approach that we say, like, I actually want to see how much condensation is actually coming out from my roof. Because if there's more than just condensation, then it's actually a water leak. You actually want to know. So that's why draining behind the gutter system is, I think, the best way to go. Also, if you talk about detailing the eave lining, I think it's the best idea to actually separate the gutter system from the drained and ventilated system. Because if you have a double fascia, you'll actually see there's a lot of air getting in, completely separated, and you can always choose the perfect height for your gutter. Doesn't matter what gutter you're using. Another one, which is one of my projects, is another one. So you have a lot of battens in here because this is going to be a slate roof. What I did, I always, on my projects, even back in Germany, I always had custom-made flashings as a trap flashing. Because whenever you have water coming through, you don't want that the water end up in timber, FC sheet, whatever. And that's what I said before. You always have the water pools and the water spots on your eave lining. That's actually not nice to have. So I always want a dedicated dripping edge, and I actually stick the roof membrane on top so you create a natural overlap. Then you have this ventilation layer, which is actually separated from the front part of your first purlin. And then you just put your fascia board in front of it, and you have a really nice system. And it looks very slim and nice too. It's another way how to do it. Also, that's more like an architectural one from New Zealand, which you can see also. It looks nice if it fits, of course, to your house. What I'm just trying to prove here is there are many, many ways how to do it. It's long. I just care about if you actually get enough air in and if you get water out properly. So you will also find most of the pictures in the study too, so you know. As we have the eave lining, what's happening actually at the ridge, because air has to get out at some point. On the left picture, the mesh is just purely for vermin protection, nothing else. And on the right picture, under certain conditions, you actually need to ventilate your truss roof, which we're going to talk about in a second. But roof trusses, they actually have to be ventilated by code. So that's why when you have actually a scallion roof or rafter roof, you're actually able to really wrap your whole building because you don't have to ventilate your truss in this case. And the ridge steel, of course, is significantly tighter than if you have to try to organize some overlaps. And I think the ridge is the easy part, but when we talk about hips and valleys, specifically valleys, there's a lot happening there. So first of all, you really have to be careful that you really leave the valley open so water can really properly drain out. Because you see, like, you have to drain so many different voids of your roof. If you block that one up, you definitely have stagnant water on your roof. And also, again, air has to get in. So just with the valley line, you see, like, you have to feed, in this case, around 8 to 10 roof voids because you want air to get in. So that's why the clearance in the middle of the valley is very, very important. And my favorite, when we talk about roofing features, specifically skylights, because everyone like to have a skylights. I think I installed maybe 200-300 in my life. That's why I call myself experienced skylight installer. And one of my experiences I had quite a few times is if you miss actually the internal gutter above the skylight. So it's very important, doesn't matter if you have condensation, whatever it is, you have to deflect it. Because over the time, we talk about 10, 20 years plus, this can actually fail. So the integrated gutter is significantly important. Also important, there are two different types of skylights, specifically the Velux ones. They are the US type ones and then the ones from Germany, from Europe. And the performance is significantly different. So these ones are definitely going to act a little bit like a thermal bridge because they're sitting out of the roof a lot. And the European ones, they're really sitting very deep in the window. They have insulated frames. So it's just, I think, interesting to know there are two different types. But if you use like the US style, like here, you definitely have to wrap like with a normal window. You actually have to wrap it around all the way up. You have to tape all the corners. And after you taped all the corners, then you actually can install the window on top, and then you can actually tape it properly. Because otherwise you don't have a continuous connection from the window to the WRB layer on the roof. And as I said, like the internal guttering on the roof is very, very important. I had to fix way too many, so that's why it's important. Also a feature, how Jesse mentioned before, to protect the view of the harbor or the ocean, or maybe just a few kangaroos passing by your building. It's actually flat roof. So if you have a flat roof, there's a specific system. And the important part of the system in this case is actually to prime the overlaps, because the roof pitch is so low that actually water is going to take a while to drain off because it takes such a long time. And if you have a bit of a wind pressure, you actually have standing water on the roof potentially. And that's why you have to stop the capillary in the freeze to go back. Also, really to pressure activate, use the press fix again to have no wrinkles. That's very, very important. As I think it's a relatively easy part now to install the external part of the building. So what's happening on the inside? Is it different? Is it no more difficult? Because a lot of people actually are a bit afraid of airtightness. And the answer is no, it's actually not. So the installation methods, the details are technically all the same. So if you're going to have the first time that you're going to install an intelligent air barrier on the inside, it's the same as easy as it is on the outside. You follow the same steps, and also it's important it's always consistent. So you don't just have intelligent air barriers on walls and not on the roof. It should be always all the way around, like here on the ceiling. Continuity is very, very important. And also important is actually, how do you start it? When do you start thinking about the airtightness layer? Should it be DA stage or when you plan? I would say actually latest when you start framing, you should know what your details are. Because if you just look here, you have an internal wall here. How did I make the internal run behind this internal wall? In this case, it removed the wall and run it through because it's not a load-bearing wall. So that was an easy one. But if you actually have to pre-think what's happening on site, and like here, so it means you have to pre-install air tightness strips on the way. So we call them connection strips. So you have to install the connection strips during the construction phase and during the framing stage. Because otherwise, you're going to introduce a lot of work to try to fix it. Also, it's important to use the right one because as you now expose an internal product to wind and weather, you can't actually do it. So that's why there's specific products. We have specific products. They're actually UV resistant and weather resistant. This is then how it looks like. It's still the old product, but you just wrap it up and over the top plate, and then you create a continuous layer, continuous air tightness layer. But as you can see, because now you have to connect the internal air tightness layers to the connection strips, it can be quite time intense. And what's more important and more expensive? Is it the products or is it actually the workmanship? And I think we all agree it's the workmanship. This is when we drive up the costs. So let's actually simplify the structure. You could save 1 or 2 weeks of labor at least if you just have the chance to avoid all these connection strips. One way would be, for example, you just drop the ceiling to minimize the ceiling connection strips, or you leave off the internal walls temporarily, or you leave internal walls a bit shorter, like 600 millimeters, or use temporary fixings. So if you can reduce all these tips and tricks, you just cut down weeks and weeks and weeks of labor. And this is how you actually save money. Also, how are you actually connected to the concrete slab? So do it once and do it right, because if you connect it properly to the concrete slab, you have a durable connection and you don't have to fix it even during the construction phase over and over again. It's about durability here. How I say, prime as king. But specifically in Australia, the way how we build houses, they're definitely a little bit more architectural. Because when you go through Germany, we just have square boxes with a gable roof. That's it. I definitely wouldn't say that we have nice houses in Germany, but I can tell you they're effective and they're fast to build. So that's why it's important to understand all these potential problems. And that's why I like Jesse's little video there, because if you just have this 1 millimeter on the wrong conditions, this is what's happening. So whenever you introduce, as a designer, as a builder, whenever you introduce architecture features, just be aware that you introduce extra time and you need to put more attention into the detail. That's very important. I'm not saying it's impossible, but just be aware you introduce extra time. Always. And next important part is also we'd have to talk about services, how to actually run it. And again, simplify it. The easiest ways to really introduce always a dedicated installation area of 35-45 millimeters. I know it's a big no-no for a lot of people, and because you lose floor space. But as we introduce more insulation, you could have a 90 mm frame and you just put insulation on top of in your insulation area. So you increase the R value of your whole structure. And you have a dedicated installation area where you run cables and pipes, because this is the best way how to protect the membrane for damage. Also, the Sparky loves it. On the day 1, Sparky will come in and just like, oh, I don't like it, and it's so complicated. On day 2, he's going to run around with a big smile on his face, because he's going to save a lot of time, because he doesn't have to drill 100 million holes through the studs, because he just runs the cables behind the counter batten or behind the installation batten. This is a typical one, for example, when you have horizontal battens, if you have a vertical install of plasterboard. It's a bit revolutionary in Australia to recommend vertical plasterboard installation because no one does it. So just turn it around and you still actually can use it. And you just have to cut your battens shorter, because this is the best way how to actually allow free space for your battens to run and your installations. It's quite important. Ceiling services is a very interesting one, because I think that's always underestimated. And when we talk about ceilings, we actually want to hold the membrane in place, but we also have to consider what's actually happening with the insulation of the weight of the insulation. So the choose of the insulation layer and the thickness of the insulation is very, very important. Still, a lot of people think that the blue strips, how we actually hold up the insulation, is holding the insulation in place. And everyone who installs the Intello layer on the ceiling knows, no, it doesn't really. So if you try to really install the Intello properly, you actually really have all the stress sitting on the membrane. If you now go to a high density insulation, like blowing in insulation, for example, you still have to consider that the membrane actually has to hold all the load. And that's why it's important to really follow all these steps. So if you have blowing in insulation, where you have a high load sitting per square meter, you really have to increase the numbers of battens and the staples also. You really need staples every 50 millimeters. Because normally it's not a big problem when we have fluffy stuff, like on the right picture. But you see on the right picture, there's just between the two battens, there's just one staple. And this can be difficult, because if you do a blowout test or whenever you have wind pressure, all the stress will sit on one staple. That's a lot of stress for one single staple. So in this case, maybe I would put a tape on top. And that brings me to my next topic, roof trusses. So it's a bit contradictory to energy efficiency because we always say we want to protect our insulation layer properly. So just trapped air is good insulation. But we have a truss roof. And specifically when we look to Tassie and colder climate areas, we know we had massive issues and condensation issues with truss roofs. Because you have this massive air void of still standing air, you can't really calculate properly how much moisture actually you can accumulate before you have problems. And specifically, even if you don't have an intelligent air barrier, all the moisture might just rise up into your ceiling structure. So that's why the building code requires you have to ventilate your roof truss. And there's a reason why in Europe we don't use roof truss in resi builds. Because to make this one work, you heat it or you actually ventilate it. And when we talk about the ventilation, in this case, we not just talk about above sheeting ventilation, you actually have to properly ventilate the insulation layer. Means, again, you reduce the performance of the insulation. So this is a little bit, we'll say, the system is between a rock and a hard place at the moment. As we now ventilate the roof space, who's handling now the wind pressure, wind gusts hitting the building? It's actually not the WRB layer anymore. It's now the airtightness layer on the inside, intelligent air barrier. So whenever you install a ceiling air barrier, you just have to consider now they actually have to handle the wind load too. And that's why it's very important to really properly secure it, follow the guidelines to really get a proper install in this case. Yeah, look, I forgot this comment. Yeah, the roof is like a box of chocolates, one of Jesse's favorite comments. Specifically around building science in Australia, isn't it? So the ideal solution, as I said before, a smart person told me, a perfect roof is like a perfect wall. And whenever you can, always try to have a rafter roof because this eliminates most of these problems. As we now run all the battens through your systems, you have to talk about the fixings because most times, which is more passive house detail, you have suspended ceiling because you want to run all your services and your ductings also. I want you to fix them all on the battens and don't penetrate the membrane in this case. I also just want to mention the right picture because I like it. It's really nice and organized. It always looks nice when everything's straight. Because it's easy to plan too. When we talk about fixings and clip fixings, that's a tricky one because you have the sharp corners and you just have point fixings again. We always recommend having continuous support of the membranes, inside as outside. That's why this is, in my opinion, very tricky because that's just a point fixing. It's not a continuous fixing at all. And we talk about durability. So you might pass the first airtightness tests, but you want to pass it in 20 years too, or 30 years. You can run, of course, the battens on the ceiling both directions. Of course, it's much easier if you run it crosswise because, again, the installation layer is much, much easier. If you run it lengthwise with the purlins or with your roof structure, then you actually have to run maybe eventually the cables from above, or if you have direct plasterboard. But then you see like it makes the install of the cables, of your reference a little bit more difficult. And also I want to point out the purple cow in the corner. I don't. So what's different here in this picture, what you actually can see is it's hempcrete, it's a hemp building. But I actually don't want to talk about the hemp. I actually want to talk about how you actually connect airtightness membranes to render systems. And you just think about, it doesn't make any sense in Australia, but it will, because, for example, if you retrofit a brick building or a double brick building, you always might keep your roof structure and you will keep your rendered system on the walls. So this is the way how you actually connect it. So you use a specific tape and you actually have to render it in. So you put a layer of render on, press the fleece on and the mesh on, then you put another layer of render on top of it. So there's an easy solution there. I'm just saying it's actually easy accessible. Grommets, the same as always, as inside as outside. Whenever you introduce structural or architectural features, even visible ones, just be aware, a lot of taping needed. The best way specifically for new builds to cut on time to cut down costs, and specifically, as we're all aware, that mold problems is going to get a bigger and bigger issue because we have materials then very mold sensitive too. So if you leave these materials exposed to wind and weather for weeks and months, chances of any mold problems are very, very high. So what's the answer to it? You know it already? I would say like factory plant systems. So over time, we're definitely going to move or improve actually using a factory plant system, which we say prefab. And I'm not talking about prefab necessarily where you need like 200, 300, 400 houses a year. So you can even do it in small scale. Like Evan Graham is relatively small, I would say, not small. But you always have the controlled environment inside. You have fixed work times. It's always dry. It's comfortable. You can set it up so you actually don't have to work on the floor, but they have the table on the right side. But you just put your framing together. It's dry. Membrane on. It's dry. You fill it up with insulation. It's still dry. You flip it around, put the interlayer layer on, and the whole system is dry. You sort. You store it properly. It's still dry. And then you go inside. You install it. Maybe it takes you 1 week, 1.5 weeks. And after, let's say, 2 weeks, your whole building is set up at latest and it's dry. If there would be a rain coming, you don't care about wind normally. If rain is coming, you just put a massive tarp over to protect your building structure. Because there's nothing worse in prefab systems if you drown them in water. And no, yes. The same is with CLT. Always protect your CLT from the beginning, day one. If you leave your CLT exposed to wind and weather, you're going to spend a lot of time eventually, in worst case, to remove mold, or you need a lot of time of sanding to sand off all the watermarks. And I know from a few projects happening right now that didn't use temporary protection on the CLT panels, and they have massive mold issues now. And we're not talking about the tropics. Whatever works in big scale works also in small scale. So when we talk about this, I think he calls it passive pot. I forgot it already. You always want a dedicated weather resistive barrier layer on the outsides. You want to have a drained and ventilated structure also for your structure to dry out. And you always, even more important, you need a dedicated airtightness layer on the inside because the building is significantly smaller. So you have much more moisture on a small area. So the principles, if you build big or small, are always the same. So how would we sum it up? The way how we sum it up altogether is we need quality products, quality design, and we also need quality workmanship. And when everything comes together hand in hand, then I think we get a quality outcome for a proper build. And I think if you have some questions, we can talk about it and let's go into detail. That's from my end.